pyramid only. Okay, first read the given problem statement and understand so what is given and what we should do. A pentagonal pyramid, 25 mm sides of base and 50 mm axis length, rests on HP. On one of its slant edges, draw the projections of the pyramid when the axis appears to be inclined at VP at 45 degree. Okay, if you compare with the previous problem statement, you can find few differences between previous and this problem. Okay, in the previous problem, so you can find inclination with HP and VP. Okay, inclined angle with HP and VP, and it is resting on corner. Okay, here, so you have only inclination with respect to VP, that is given. Inclination with respect to HP is not given, and also it is resting on slant edge. Okay, there is a difference between base edge and slant edge. First thing is, you should identify the difference between slant edge and base edge. Okay, so what do you mean by base edge in a pyramid? Which one do you call as base edge in pyramid or base edges? Okay, in this solution, okay, which are the base edges? Okay, anyone can answer for this question. Which are the base edges in this pyramid? So here is the solution. I named it as A, B, C, D, E, and I named axis as O, O1. Okay, now which are the base edges of the pyramid? Of this pentagonal pyramid? Rakshita?
Yes, sir.
Which are the base edges of the pyramid? So if you consider this pentagonal pyramid, which are the base edges and which are the slant edges? Base edges ಯಾವುದು, slant edges ಯಾವುದು? Okay, now, okay, I will name, okay, AB, okay, whether AB is a base edge or slant edge. AB, whether it is a base edge or slant edge.
Slant edge.
AB. Okay, any other answers? Whether AB is a base edge or slant edge. Okay, so if you don't know the difference between base edge and slant edge, it will be very difficult. Okay, so first you should understand. So what do you mean by base edge and what do you mean by slant edge? Okay, so in previous class also I explained. Okay, consider this as a pyramid. So this is the base of the pyramid. Okay, that means which is on HP. Okay, so this is called as base. So in case of hexagon, A, B, B, C, C, D, okay, E, F. So those are the base edges. Whereas slant edges means, so they are the lines connecting corners of the base and apex. Okay, in case of pentagon, there are 5 corners A, B, C, D, E, and only one apex. Okay, that means lines connecting corners to apex. So they are called as slant edges. Base edges means edges of the base. Okay, in case of pentagonal pyramid, base will be pentagon. The edges of the pentagon are called as base edges. In case of hexagonal pyramid, hexagon is the base. Okay, the edges of hexagon are called as base edges. Okay, slant edges means, so these are the inclined lines connecting apex to corners of the base. So here, this is one of the corner of the base. So a line connecting this corner and apex. Okay, this is one slant edge. Similarly, a line connecting this corner and apex. This is one more slant edge. So a line connecting this and this. This is one more slant edge. Okay. Now, so consider the problem statement. So it is resting on one of its slant edges. So slant edges may be A to O1, B to O1, E to O1, then D to O1, C to O1. These are the slant edges. Okay. So here instead of giving inclination with respect to HP, so they have given the condition that so it should rest on HP on one of its slant edges. Okay. So this if we satisfy this condition, the axis will make certain angle. Okay. We need not worry about the inclination of the axis. Okay, first thing is, so we should satisfy the condition of it is resting on HP on one of its slant edges. Okay, then we should satisfy the inclination with respect to VP. Okay, whether it is resting on corner, whether it is resting on base edge, or whether it is resting on slant edge or slant face, initial position remains same. That means initially you should keep solid in vertical orientation so that in top view you can get the true shape of the base, and in front view you can get the true height of the pyramid, that is true length of the axis. Okay, in such a way you should keep the pyramid. So like this you should keep the pyramid for every problem. You should keep the pyramid like this only. Okay, for this problem also initially pentagonal pyramid will be kept in this orientation in such that the axis of the pyramid will be parallel to VP. So that means in front view you can get true height or true length of the axis. Then in top view you can see the true length of the base because the base is on HP. That means base is parallel to HP, so that you can see the true shape of the base in top view. Okay. First here also first I should draw the top view. Since it is resting on slant edge, slant edge means line connecting A to O1, a line connecting E to O1, B to O1. Okay, so these are the slant edges: A to O1, B to O1, C to O1, D to O1, and E to O1. So these are the slant edges. So initially, if it is resting on slant edge, we should consider it as resting on corner initially. Okay, if it is resting on slant faces, we should consider it as resting on side. Okay, that you will understand later. Now, so draw the top view by taking the condition as resting on corner initially. Okay, and then draw the front view. Okay, so I will draw the initial views using Solidworks. First I will draw XY line. Okay, next, so by using interior angle method, so I will draw pentagon. Length of the sides is given 25 mm sides of base. So base edges should have 25 mm length. Okay, after this, you should use compass. So draw two arcs, taking 25 mm radius. Okay, next, so after drawing pentagon, so I will name it. I will name the corners of the pentagon. Okay, next after that, since it is pyramid, okay, from top view, you are able to see the slant edges. Because of inclination, the length of the slant edge get reduced. That is a different issue. But in top view, we are able to see the slant edges. Okay, so we should represent the slant edges. Slant edge means, so you should connect apex to all corners. So in top view, this apex will coincide with the center of the base. Okay, first I should find out the center. For that, I should draw two perpendicular bisectors from any two corners. Okay, first I will consider A. From A, I will draw a horizontal line. So this horizontal line will be the perpendicular bisector of CD. That means this line will divide CD into two equal parts. Next, similarly, so I will draw one more perpendicular bisector from corner E. It will bisect, or it will divide CB into two equal parts, BC into two equal parts. Next, after drawing two perpendicular bisectors, so I will get the center. So the reason of getting this center or locating the center is, so we should represent axis. Axis is the line connecting center of base and apex. So in order to represent axis, and also we should represent all slant edges. So that means slant edges means, so we should get the apex. In top view, apex will fall on the center of base. Okay. So next, so I will connect all corners to center. Then next, so I will erase this perpendicular bisector. So next, so I will name the axis. So apex, I can see apex from top. So O1 is visible. Next, center of base is invisible from top. Okay, that means, so if you look from top, you can see the apex, but center of base is invisible from top. That's why in top view, apex is visible, center of base is invisible. Next, so after this, so I will project the points and I will get front view. Also project points of axis. Next, so after projecting points, so I will make it thick. Then next, so I will name these points. Dash. Next, so I am looking from this direction, so E will be visible and B become invisible. So E dash and B dash inside the brackets. Next, so from front view, center of base is invisible, whereas apex is visible from front. Okay, if you look from front, you can see this apex, whereas center of base you cannot see. O1 dash. and O dash inside the. Okay, next. So here T is visible and C become invisible. Okay, so after this, next thing is also very important. So you have the height of the pyramid. You know the height of the pyramid. So in this case, the height of the pyramid is 50 mm. A pentagonal pyramid, 25 mm sides of base. So the length of the sides of base, that is this pentagon, is 25. Okay. Next, 50 mm axis length. This axis length define the height of the pyramid. Okay. Axis length rests on HP on one of its slant edges. Okay, so consider axis, that is O1 dash, O dash and O1 dash. So on the point of this axis, we should draw chain dash line. Chain dash line is used to represent axis. Okay, and this height should be 50. So after drawing axis, then connect. So you will get the apex by drawing the axis to the given length. Next, connect apex to points of the base, that is corners of pentagon. Okay, so these are the slant edges. Okay, then I will name the apex. Okay, sorry. So here in front view, so since it is base edge, okay, here only just O dash inside the bracket O dash. Okay. So apex in the front view, apex will be at top. Okay, so this will be O1 dash. After this, next we should try to satisfy the given condition. The pentagonal pyramid, 25 mm sides of base, that we are able to represent in the top view. Next, 50 mm axis length, this we are representing in front view. Rests on HP on one of its slant edges. Now the complete base is on HP. Okay. Even though the given condition is different, we are considering complete base on HP because we want to get true shape of the base in top view. Okay, for that reason we kept complete base on HP and we took top view and also we took front view in order to get the actual height, that is true height of the given pyramid. Okay, next, so we will go for satisfying the first condition. Rest on HP on one of its slant edges. Okay, here A dash O1 dash. So this is one slant edge. Next, this line represents two slant edges. One is D2O O1. Another slant edge is C2O1. This line represents two slant edges. This line represents only one slant edge. Okay, and here, so this line also represents two slant edges. So here it should rest on one of its slant edges. So that means I should consider only one slant edge. So that means if I take resting corner towards right, I will get this slant edge, one slant edge towards right. Or else if I take side towards right, okay, so this slant edge will be towards left. Okay, so that's why in case of resting on one of its slant edges, so consider the corner towards right. So in second position, what we should do is, so we should tilt this front view. This should be tilted. It's such that it should be tilted in clockwise direction, such that this A dash and O1 dash will be on this XY line. Okay, slant edge rests on HP on one of its slant edge means on HP means this slant edge should be on XY line in front view. So now, so I will consider a point on XY line. Okay, this will be O1 dash. So if I make it, if I rotate such that this will come down, so O1 dash will be at this location and A will somewhere here. Okay. So now, so I will measure the radial distance of this slant edge using compass. Then, so mark a point on XY line. So and name it as O1 dash. Next, so consider one more point at a distance of 54.21. So this distance should be 54.21. Okay. So now I will draw a line connecting these 2 points. And I will name it as A dash. Sorry, this I will name this as O1 dash. And this is A dash. Okay. So now I took radial distance between this slant edge, that is point A dash and O1 dash. Then I marked O1 dash on XY line. Then taking the radial distance between O1 dash and A dash, so I will get the point A. Then I will connect and I will get this line. Okay. So after that, now you have O1 dash and A dash on XY line. That means this is a slant edge. According to given condition, it should be on HP, that means on XY line. Next, I should get remaining points. If I know O1 dash and A dash, easily I can get D dash and C dash. Okay. For that, so you should use compass. So using compass, take the radial distance between O1 dash and D dash C dash. Next, radial distance between so A dash and D1 C1 dash. Okay. So now O1 dash as center. I will draw an arc. Radius will be 52.89. Next, A dash as center and A dash D dash as radius. That is 38.18 as radius. We will draw one more arc. Okay, so this point is D dash C dash. Next, so I will connect this point to these 2 points. Okay. So then I will name these 2 points E dash, E dash. Okay, next, so I got A dash, D dash, C dash and O1 dash. Okay, next thing I can get these 2 points of base. Okay, that means I have this line A dash to D1 C1 dash, A dash to D1 C1 dash. So next I should get these 2 points. Okay, again I will using compass, so you should get these 2 points. Okay, I will measure radial distance between A dash and E dash. Next, similarly, I will measure radial distance between A dash and O dash. Okay, so next, so you should use compass. So I am using the center pointer. So A as center and radial distance between A to E, that is A dash E dash. This radius I will draw an arc. Okay, next again A as center and radial distance between A to O as radius I will draw an arc that is 20.95. Okay, like this, so I will get okay, next, so I will name these points. So this is E dash, B dash, and this is O dash. Okay, next, so I will connect these points to apex. So this will be axis line. So I will make it chain dash. A thin chain dash line. Next, slant edge. So now I will increase the thickness of slant edge and base edges. Okay. So what I did was, so I redraw the same front view in different orientation. Okay, same front view in different orientation. So drawing front view such that one of the slanted, that is A dash O1 dash on XY line, in order to satisfy the first condition. Next, I should project the points and I should get the second top view. So first I will project the points and I will get the second top view. So O1 dash. Next, D dash C dash. Next, O dash. Next, E dash B dash. Next, A dash. Okay, so after locating the points, so I will name them O1 dash. So here, since it is top view, so just O1 without prime. Next, so point A. Next, B. Next, C. D. E. Okay, so next, so after locating the points and naming them, so now before going for connecting them, so we should apply rules of visibility. Okay, rules of visibility is applicable whenever we are drawing second top view and final front view. In these two, for these two views, so we need to look into rule of visibility in detail. Okay, the first rule of visibility is join all boundary points. Okay, already I shared when you have gone through the classwork, you might have noticed these things. Okay, rules of visibility. So join the boundary points with continuous lines. That is the first rule of visibility. Now I will follow this. I will connect boundary points. Boundary means, so nothing will be left beyond that. No point will be left beyond that. Inside the boundary, there may be few points. Okay, I will start from here. So this is the boundary. So I have followed the first rule of visibility, join all boundary points. Okay, next, so after this, okay, next thing is, so we should look into the second rule of visibility. Draw visible edges or nearest face with continuous lines. Draw invisible edges or farthest face with dashed lines. So now this is the position of the observer. Okay, this is apex and this is base. Okay, so if this is the position of observer in top view, so it's looking from top. Which is nearer to observer, whether base or apex? Which one is nearer to observer?
So base.
Base. Okay. So if base is nearer to the observer, then it will become visible. If base is nearer to the observer, then base will become visible. That means all base edges will be represented with continuous line. Okay. Now, since in case of pyramid, we are comparing base and apex. Okay. If base is nearer, it will be visible. So now I will connect remaining base edges with continuous lines. Okay. For boundary it is not applicable. If the edges come on boundary, whether they are visible or invisible, we need not worry. Okay, boundary should be always represented with continuous line. Okay, so I am applying second rule of visibility, that is, since base is nearer to observer, so all base edges will become visible. So I will connect base edges with continuous line. A to B already on the boundary, B to C I will connect with continuous line, then C to D continuous line, then D to E continuous line. Okay, next, so already we connected base edges and few slant edges which already come on boundary. Okay, next, so we should follow remaining rules of visibility. Okay, so if we should connect all corners of the base to apex. That means we should connect E to O1 already on the boundary, D to O1 we should draw, C to O1 we should draw, B to O1 already on the boundary. So remaining, there are three more slant edges which we need to draw. Okay, for drawing slant edges, remaining rules of visibility are applicable. If a corner, that is, consider corner D, it is connected by two continuous lines. If a corner is connected by two continuous lines, then give first preference to drawing a continuous line. But for this, there is one additional condition. Okay, when you go for drawing a continuous line, it should not cross one more continuous line. Okay, if you go through rule of visibility, you may understand slightly. While following, you will get it completely. Okay, if two sides joining a corner are continuous lines, then the other side projecting from the corner is also a continuous line. But to this condition, you should add this also. Two continuous or two discontinuous lines do not cross one another. Okay, so these two are interrelated. Now, so I will go for connecting D. Okay, since it is connected by two continuous lines, first I will try continuous line because it is connected by two continuous lines. So when I go for drawing a line from D to O1, Okay, it is not crossing one more continuous line. It is not crossing. So it is possible. Okay, it is a visible line, visible slant edge. Okay. Next, similarly, so C. Okay, it is connected by two continuous lines. So first I will go for drawing a continuous line. It will not cross one more continuous. So I will make it there. Next, I should connect A to O1. Okay. Since A is connected by two continuous lines, so I will go for drawing one more continuous line. But the problem is, so it will not obey the last rule of visibility. That is, if I go for drawing a continuous line, okay, and if I make it thick, so now you can see this continuous line is crossing this vertical continuous line. It is not possible. According to last rule of visibility, two continuous or two discontinuous lines do not cross one another. So that means I should go for remaining option. So that is, this should be a discontinuous line. That is dashed line. Okay, this is possible. So like this we should connect. Okay, so axis I cannot represent because so it will overlap with the slant edges in the second top view. So only thing I can do is, so I will name the point. Okay. Next, so I should satisfy the next condition. Okay, so draw the projections of the pyramid when the axis appears to be inclined to be at 45 degree. Okay, now while drawing the final top view, okay, so beta angle come into picture, whether we should find beta angle or not. Okay, so in this case, is it necessary to find beta angle? Beta angle find out ಮಾಡಬೇಕಾ? Okay, before that, so draw the projections of the pyramid when the axis appears to be inclined to be at 45 degree. Whether this given inclination is true inclination or false inclination.
False inclination.
False inclination. Okay. Why it is false inclination? Because so they use the term appears to be. Okay, this will give you an hint. Okay, regarding the given inclination is false. Okay, since false inclination is nothing but that is the beta. Okay, given angle itself is beta, so that's why need not find out beta. Okay, we have false length of axis. So here you can see draw the projection of the pyramid when the axis appears to be inclined to be at 45 degree. Actual true length of the axis is 50 mm. Now measure the length of the axis in second top view. Okay, if I measure the length of the axis here, it is 46.21 mm. That means the length of the axis got reduced. The reason for it is so because of the inclination. When we try to satisfy the first condition, that is resting on slant edge, this axis also will become inclined. Because of this inclination, the length got reduced. Okay, because we have false length of the axis in the second top view, so we should make it inclined to false angle. So that is given in the question itself. Okay, next I should redraw the same second top view such that the axis will make 45 degree with VP. Okay, either you can draw a 45 degree line from XY line if you have sufficient space available towards right side, or else in order to save space, what you can do is so draw a line parallel to XY. Draw a line like this. Okay, next, so draw a line inclined at 45 degree. Okay, if you have any doubts or any questions, you can ask. Okay, feel free to ask questions or ask doubts. Need not worry. Okay, so if you have any doubts, you can ask. Okay. Okay, so next, so after drawing a line inclined at given beta angle, that is 45 degree. So mark the points. Okay, on the 45 degree line, I will get the axis, that is O1 and O. Okay, first, so I will consider a point. So I can consider here itself, no problem. So I will consider this as O1. Next, so you should use compass. So take the radial distance between O and O1, that is 46.21. Okay, next, using compass, so on this 45 degree inclined line, I will get point O, 46.21. Okay, next, so on the same line, if I extend this line, I can get point A also. So this is, if you observe properly how we can redraw it, you can get all these things. Next, so I will measure the radial distance between O1 and A. So it is 54.21. Okay, again O1 as center and radial distance between O1 and A. So I will draw an arc, 54.21. Okay, so after this, I will name the points. So this is O and this is A. Okay. So now I have points A, O and O1. I should get point B, E, C and D. Okay. So since I know O1 and A, easily I can get point B. Okay. That I will do first. So you should use compass. So I will take the radial distance between O1 and B. Next, radial distance between A and B. Then next, O1 as center and radial distance of between O1 and B as radius of the arc. I will draw an arc, 52.76 as radius. I will draw one arc. Next, A as center and 21.18, that is radial distance between A to B. I will draw one more arc. A as center. And 21.18 as radius. Okay, I will draw one more arc. So now I will extend this arc. Okay, so I will get point B. So this is okay, similarly, I can get point E. Okay, again radial distance between O1 and B and O1E both are same. So from O1 I will draw an arc. Radial distance is 52.76. Okay, next, A as center. So and radial distance between AB and AE both are same. So 21.18 is radius. I will draw one more arc. Okay, so this is point E. So after getting points B and E, I should get point C and D. Okay. Either I can go for drawing two arcs by taking radial distance between BC and O1C. I can draw two arcs, I can get point C. Similarly, taking radial distance between E and D and O1D, I can draw two arcs and I can get remaining point. That is one procedure. Other than that, so I can get it in one more procedure. Okay, that is, so I will consider this line. Okay, the line CD. Line CD is perpendicular to line OA. Okay, O1A already I have drawn. CD, it is perpendicular to O1A. So I should draw a line perpendicular to O1A, and where I should draw this perpendicular line, that will be decided by radial distance between point A and this point. Okay, first I will measure the radial distance between A and this point, that is point on CD, line CD. Okay. I will consider this radial distance. From A, I will draw an arc. Next, so I will draw a line perpendicular to this 45-degree incline. From this point, I will draw a line. So you should use your, if you are following this procedure, you should use scale and protractor. Okay, it should be perpendicular. Like this. Okay. So next, after drawing a line perpendicular, okay, next, so take distance between this point and CD to this C. Okay, so that is half of it. 12.5 you should get. Since CD is 25, so half portion, this is center of CD. Okay, so you will get 12.5. Okay, so now this as center and 12.5 as radius. So I will draw two arcs. Okay, so this is point C, and this is point D. Okay, so after that, so again I will connect. So here I should not worry about rule of visibility. So since I am reproducing the same second top view in different orientation, okay, I need not worry about rule of visibility. If it is continuous line in second top view, here also that should be continuous. If it is a discontinuous dashed line in second top view, here also that should be a discontinuous line. Okay. Other than that, you need not worry. So you should draw as it is in different orientation. First, I will connect boundary. Next, base edges. Okay, now to avoid confusion, first I will connect all boundary points. So next I will connect base edges. And then I will draw slant edges. Okay, next, so I will draw one more slant edge. Okay, so this is the final top view. Okay, next, so I should get the final front view. For that, so I will project points from the top view and front view. Next, A. Okay. Okay, next, so I forgot to name the points. So this is D. Okay, so next, so we'll draw projector of C. Okay, next D. Next E. Next axis O. Okay, after projecting points, so I will name them. So this is O1 dash. So this is D dash. C dash. A dash. E dash. This is O dash. Okay, so after getting the points, okay, now once again we should apply rule of visibility. First rule of visibility is we should connect all boundary points with continuous line. Okay, I will start from O1 dash. So I connected all boundary points. Okay, this is the first step. Next, again I should apply rule of visibility. So this is the final front view. I am looking from this direction. Okay. So here also, since this is a front view, I am looking from this direction. Base will be nearer to observer when compared with apex. Okay. Now because base is nearer to observer, base is visible. So it means all base edges should be continuous. So A to B already on the boundary. So B to C, that is B dash C dash already on the boundary. C dash D dash already on the boundary. Next D dash to E dash, it should be continuous. Next E dash to A dash, that also should be continuous. Okay, next I should connect all corners to apex. A to O1 dash already on the boundary connected. Next B dash to O1 dash. Since B dash is connected by two continuous lines, first I will go for drawing a continuous one like this. But now you can see when I go for drawing a continuous line, it is crossing one more continuous line, that is A dash E dash, which is not possible according to last condition. So only leftover option is I should make it discontinuous. So that means this is a invisible slant edge from in this orientation. Next, I should draw slant edge from C dash. So since it is connected by two continuous lines, if I go for drawing one more continuous line, again it is crossing D dash E dash, which is a continuous line. It is also not possible, so I will make it dashed line. Okay, next D dash O1 dash already on the boundary. Next E dash O1 dash. So I should draw a line. Since E is also connected by two continuous lines, okay, so I will go for drawing one more continuous line. So this line is not crossing any other line, so no problem. I can retain it as a continuous one. Okay. So next, I should represent axis if possible. If axis is not overlapping with any of the slant edges, then I should represent axis. Otherwise, so you may lose marks in the exam, and that is not proper way of representing a solid. Okay, so if it is possible, you should represent the axis also. So I will draw a line connecting O1 dash and O dash. Okay, next chain dash. Okay, this is the final view. Okay, so here you can see A1, A dash, O1 dash. So in the final view also, A dash, O1 dash, it is on XY line. That means this is the view of the solid, that is pentagonal pyramid, when it is resting on slant edge on HP and the axis is making 45° with VP. In this orientation, if you look from front, it will be represented like this. That is the name. Okay, so I will consider one more problem. This I don't solve. I will give it as classwork. A pentagonal pyramid, 25 mm sides of base and 50 mm axis length, rests on HP. On one of its slant triangular faces, draw the projections of the pyramid when the axis appears to be inclined to VP at 45°. Okay, so compared to previous problem, remaining all are same. Only one difference is instead of slant edge, here you are having slant triangular faces. That means it is resting on slant face. Slant face consists of 3 points. Okay, so that means ABO1 is one slant face, BCO1 second slant face, CDO1 third slant face, DEO1 one slant face, EAO1 this is another slant face. These are triangular in shape. Okay, so they are the slant faces. Now if it is resting on slant face instead of slant edge, you should consider it as resting on edge. Okay, you should take the edge towards the right, so that here you will get 3 points. Okay, then in the second front view you can satisfy this condition. Okay, so I will show the solution, partial solution. Okay, so for this problem resting on slant triangular faces. Okay, so take this side, resting side towards right. So why you are taking side towards right means so that in front view you will get 3 points. EAO. This is a triangular face. Okay, so in the second front view you can see EAO, 3 points on XY line. That means triangular face is on HP. Okay, we will get the second top view. Then here also same appears, so need not find out beta angle. So directly make it inclined at 45 degree, redraw. Okay, then project the points and get the final view. That is the procedure you should follow. Okay.